Hello all, welcome back to my YouTube channel all about VLSI. In this particular video, we are going to continue with UVM Testbench development of AXI-based FIFO design. Now, coming to our design, we have already seen that we are going to have a particular IP, which is nothing but AXI wrapped FIFO, where I'm basically going to have two files. One is FIFO memory, which is basically a 8 cross 8 synchronous FIFO, and it is going to have a count registers, and it is going to drive full or empty depending upon the conditions, and it is going to register D out and with 1 cycle latency after read enable. Obviously, after you are going to provide read enable, it is going to provide the D out after 1 cycle, and simultaneously read plus write keeps the count unchanged. And coming to my AXI FIFO slave, so it's a AXI 4 light slave, which is going to have 32-bit address and data and 4-bit strobe. And AW and W channels are going to work independently, latch independently. And it is also going to have 1 cycle read enable D delay aligns with R valid with FIFO D out. So this is what my design is, where I'm going to have a AXI wrapper, and inside this I'm going to have the FIFO, which is 8 cross 8. Now, for this, how to develop the UVM test bench, that is what we are going to discuss in our this session. Now, in this particular, you can see the component layout. We are going to have something known as UVM test, which is nothing but our base test, which is being extended from the UVM test. And whatever the different kind of test cases I'm going to generate, I'm going to write down, or I'm going to extend it from my base test itself. I'm going to write down multiple test scenarios which are being extended from my base test. And inside this test, you have something known as environment. From UVM environment only, we are going to deriving our AXI environment. And in this AXI environment, we are going to have something known as agent, AXI agent. And I'm going to have scoreboard. Scoreboard is going to have a reference model as well as checking logic which is being written inside the scoreboard itself, and coverage collector for giving the coverage. And inside the agent, I'm going to have something known as sequencer, driver, and monitor. And here they haven't mentioned one more thing, which is basically sequence. So I'm going to have sequence, and inside the sequence, I'm going to have something known as sequence item, right? All the particular fields which I'm going to randomize, I'm going to declare them in the sequence item. And different test cases use different sequences that I'm going to drive it via the sequencer to the driver, and monitor is going to monitor them. And driver, you can see there is no direct connection shown over here, but this driver is going to drive the transactions which the sequencer has sent to the interface. Okay, and this interface, it is going to give it to the design. And monitor is also going to monitor the transactions which the driver has driven as well as DUT has given that particular transactions through this particular same interface, and it is going to monitor. Okay, so both driver and monitor only are going to use the interface, and DUT is also going to use the interface. So agent as well as the design are going to, I mean, the driver, monitor, the design are going to be connected through this particular interface. Okay, no other module like scoreboard or coverage collector or sequencer or environment are going to have the access to the interface. They are not going to use the interface. Okay, now, so I'm going to have the first one. First one I should develop is the interface file. This is what we are going to develop at first, which is going to have clocking blocks, mod ports for drivers and monitors. This is what my interface is going to have. It's going to have all the collection of signals which my design as well as the test bench is going to use. And second file which we are going to develop is sequence item. So this is going to have all the properties which I need to randomize, which I want to randomize, like address, write data, write strobe, read address, and operation. Like if I want to perform a write operation or read operation, this is also being randomized. So all these particular things which I want to randomize will be present inside one file, which is known as AXA sequence item. Next is sequencer. So this sequencer is going to basically act as a mediator between the driver as a sequence and driver and the sequence. Okay. So if I'm going to have multiple sequences, this sequencer is going to have some kind of arbitration logic, which is going to take care of driving the sequences onto the driver and this is what the sequencer is going to act as a bridge. And the third one is what we are going to develop. And next is we are going to have something known as driver. So driver, it is going to drive the AXI related signals, like it is going to drive the AW channel, W channel, P channel, AR channel, and R channel. So the driver is going to have all the particular protocol specific knowledge. So driver is a low level specific component. It is only going to drive the actual interface signals. And coming to monitor, monitor it is going to capture the complete transactions and broadcast, and it is also going to collect the transactions from the driver, and this monitor is also going to collect the transactions from the design. So I'm going to have this particular driver which is being connected to the design, which is nothing but my AXI wrapped FIFO through the interface. So I'm going to have the interface which is present, and through the interface only my driver is being connected to this design. And this driver is going to basically follow AXI protocol specifications, AXI light protocol specifications, and it is going to drive. It's not like it is going to drive randomly, no. So driver should must follow the AXI protocol specifications, and it is going to drive to our design. Okay. And monitor is going to monitor whatever the transactions which were driven by the driver, so that we can have a look into what exactly we have transmitted. And also driver is also going to monitor whatever the transactions which was sent by the design. Okay, those read operations which we are going to monitor using the monitor. And next is agent. So agent is going to have a collection of sequence. It is going to encapsulate driver, monitor, and sequencer. And in our project, we are going to have the agent to be active agent. So if it is an active agent, then we are going to have all the three components enabled. And next is scoreboard. So this scoreboard is going to have a look into this scoreboard. Internally, it is going to have the reference model, and it is going to have a reference queue, and it is going to check the art data with the actual data which was written by the driver. Whatever the data which was written by the driver, that particular data, and whatever the data which the monitor is going to capture, that particular data we are going to capture, and we are going to check it out. I will explain you like what exactly the scoreboard is going to do and all. And next is coverage. So this eighth component which we are going to develop over here is coverage. So coverage, it is going to have all the cover groups and all, for basically having the functional coverage model. And the ninth one is environment. It is going to have the connection of agent, scoreboard, and coverage. And next is 10th one is our base test, where it is going to have all the components connected including the design. Sorry, not including the design. This particular base test is going to have all the components connected excluding the design. Okay, environment, agent, monitor, reference model, scoreboard, and coverage collector, and all we are going to have. And we are going to have another module which is known as top, where top is going to have the connection of our test bench plus our design via the interface. And in the top only we are going to create the instance of our interface. Okay, how we are going to create and all we'll discuss over there. Okay, so these are the different components which we are going to discuss and we are going to develop in this particular project series. So let us have a look into what exactly this interface is going to have and what we are going to develop. So interface, it is going to wrap up all the AXA4 related signals like AW, W, B, AR, and R channels, and it is going to have clock and reset signals also. And it is also going to define clocking blocks for race-free conditions, timing accuracy, and during sampling and driving. And it is also going to have separate mod ports for driver and monitor, and it is going to bound the DOT in the TP underscore top and reference it by the agent's virtual interface handle. This is what I was said previously. Using this interface only, we are going to connect our design as well as test bench. Okay, and this is where the interface is going to work, and this is what we are going to have inside our interface. Next is sequence item. So as I've said you previously, sequence item is going to have the properties which we are intended to randomize. Okay, So you can see there is one variable which is known as OP, which is going to decide what kind of operation it is, whether it is a write operation or whether it is a read operation, which is being declared as a type def. Okay, and AW address, W data, AR address, write strobe. These are all what I need to randomize them. So that's the reason I'm declaring them in the sequence item, so that I can basically randomize them. And also I'm writing down the constraints. So when I'm randomizing it, I can randomize with respect to this particular constraints. Okay, this is where I can use the sequence item. Next is base sequence. So this base sequence is basically extended from UVM sequence, and this is going to act as a parent class. This is all the directed and randomized sequence are going to extend from this common base, which is known as UVM sequence. So you can see over here, first what are we going to do? We are going to develop something known as base underscore UVM underscore sequence. It's going to act as a just a template for all the sequences which we can extend in future. Like for example, I can extend single write sequence, single read sequence, burst write sequence, burst read sequence, write full sequence, back pressure sequence, write strobe sequence, and randomized mixer sequence or reset sequence. Like this, I can have multiple sequences which can be derived in future, and this base sequence is going to act as a template. And depending upon the test cases, different kind of test cases which we are going to have, we are going to have this kind of test sequences which can be extended from this particular base sequence. And next is base sequencer. So this base sequencer, it is going to sit between my sequence and the driver. So it is going to sit between the sequences and the driver, and it is going to arbitrate when multiple sequences are going to request the bus, and it is parameterized on AXI sequence item so that the transaction type flows through it. So majorly the sequences are parameterized classes, and we are going to have the parameter as our sequence. Whatever the sequence item which we want to transmit, only that particular sequence item will be allowed. Okay, I will show you when we are going to discuss about sequencer. And it is going to expose the sequence underscore item underscore port that driver connects to via get underscore next underscore item and item underscore done. These are the tasks which we are going to have there, and it is going to instantiate inside the agent alongside with the driver and monitor. So sequencer will be present inside the agent, which is being instantiated in my agent. Okay, and next is driver. So as I've told you, driver main duty of the driver is to drive the stimulus to the design, but not only randomizing the data to the design randomly, but it is also going to follow the protocol rule or the timing rule, whatever the AXI light, whatever the AXI protocol specifications are there. Driver is going to obey them, and accordingly it is going to drive that particular stimulus, and that is what we are going to develop in our AXI driver. And monitor is going to monitor the things, and it is going to send it to our scoreboard, as well as it is also going to send it to the coverage collector. So monitor is going to use something known as unless port for broadcasting the things. Next is agent. So agent is going to have something known as sequencer, driver, and monitor. All these particular components will be connected inside my agent, and this agent is reusable self-contained unit that is going to pack all these particular three components for driving and observing the AX interface. And coming to UVM environment is going to connect agent, and it is also going to have scoreboard and coverage collector. And this environment is going to be instantiated in my base test, and whatever the other test cases which you want to develop, like like let's say suppose if I want to have a test case like randomized mixed 1,000 number of tests, so this can be derived from the base test. Base test is going to act as a template where I'm going to have multiple test cases being derived from this particular base test, like a base sequence which we have discussed, right? So like this base test also, we are going to, according to the multiple test case scenarios, I'm going to derive from this particular base test only. Okay, and how to run it and how to compile it and all, we are going to discuss in our particular series. Yes. So this is the overview of our project which we are going to develop, and this is a UVM verification environment which we are going to develop in our uh, project series. And we are also going to discuss what are the different test cases which we are going to develop, and what is the significance of each and every particular test case, those meaning and all we are going to discuss. So first what I'm doing is, first let us discuss what are the different kind of test cases and their meanings which we are going to discuss. Then we are going to start with the discussion. So in our next session, you will be seeing this particular concept, like what are the different test cases which are available, or what are the different kind of test cases which we are going to develop, and what is the significance of them. And then we are going to start with the actual development of this test benches, right? Yes, so that's about this particular video. If you like this video, please like, share, and subscribe to my YouTube channel all about VLSI. Thank you for watching this video.